you saw all the right answers to 45, yeah? Did we get to the end? My pen was crapping out, but we did get there. Good. Okay. There's a couple of things we got to talk about on page 46 in this space above the stuff we are doing. And the number one thing I have to remind you of is this property of polynomials. X plus 2 times x minus 2. If you were going to expand that completely, yes, Jacob, you just had 40 minutes to go to the washroom, and it is the 10:10 time. Yes, I'm positive. Or I can give you the shorter answer. No. What do I do here? If I was to write it out completely, I know you all know the answer, but I'm going somewhere with this. So, what do you do with that if you were in the 9th grade and you were just seeing binomial expansion for the very first time? What would you do? You would do FOIL. I don't like FOIL. I don't like that acronym, but everybody's heard it, so we would do that. I would get x squared minus 2x. Then if you were in my class, you would go to a new line, write plus 2x minus 4. And what would happen to that middle term? It would disappear, and I would be left with x squared minus 4. Now, what is it about this expression that allows that to happen? The plus 2 and the minus 2, right? It's the exact same numbers with a different operation. All right? This part is what we call, and I will write it in green, a conjugate to the first part. Okay? A conjugate is simply the same numbers, opposite operation. All right? And we already know that. We've seen that before. Yeah? Okay. So, knowing what you know and knowing that you can make a middle term disappear, look at this first question. What bothers you? Everything's a radical, even in the denominator. Now, if there was no root 10, oh, that was too big a whiteout circle. If there was no root 10 there, what would you multiply that by? You would use root 15 and root 15, right? If there was no root 15 there, what would you multiply that by? Root 10 and root 10, yes? Well, since they're both there, we're going to have to use both of them. But we have to make the radical disappear. Well, what happens when I do first? Will that eliminate a radical? Why? He waited patiently. Right, because that is root 15 times root 15, which is the root of 15 squared. There's my pair, out comes 15, right? Perfect. Will that eliminate a radical? Why? For the same reason. But unfortunately, root 15 times root 10 and root 15 times root 10 will not eliminate the radical unless what? You've got the F and the L of FOIL done. What would happen if I did the OI of FOIL right now? Will that eliminate radicals? Can I even do the OI of FOIL right now? Something is missing. What is missing? I need an operation here, do I not? Before I can do FOIL. What are my only two options? I could have plus or I could have minus, yes? Well, if I have minus, will I eliminate radicals? Look up here. Will I eliminate radicals? Absolutely not. So what must I have here? A positive. Because I must use the conjugate. So now I have, you know you're going to eliminate the radicals, right? So do you even care about the outside and the inside of this FOIL operation? Do we have to care about it? Did we care about it up here? We knew it was going to disappear, so we know this is going to disappear. So what is my first term here going to be if I write it out in as long a way as I can? We all know that root 15 times root 15 is 15. But what is actually happening here? It is the root of what? $225 or 15 squared, right? And then I'm going to subtract the root of what? I only got to do the F and the L of FOIL, so what's going here? Can eat 10 squared. And then, of course, it takes literally 1 second to do my whole denominator. What's the square root of 15 squared? 15. Minus, what's the square root of 10 squared? 10. What's 15 minus 10? 5. Now we only got to deal with the top. Again, I'm going to distribute. So what does this become? The root of what? If you were to write it out as long as possible, because this is notes, we're actually going to write it out. Be 15 times 7 plus the root of what? 10 times 7, which would get me the root of 105 plus root 70. Did either of those get any simpler? 105 is 3 times 5 times 7. Any pairs? No. 70 is 2 times 5 times 7. Any pairs? So do they get any simpler? No. And the only reason I didn't make you do that is because I know you already know how to simplify radicals. We are dealing with this part of the business now, yes? This is what my concern is right now. I know you can all simplify radicals. Okay? All right. So knowing what you know, right here, there's a bunch of white space. We're going to do some talking here. If I had x plus 2, and I wanted to get rid of my linear term, what would I multiply by? X minus 2. Okay. Now we have just used that knowledge to tell us what to do if we have root x plus 2 times, what would go here? Root x minus. Remember when my phone didn't work? Wasn't that awesome? I miss those days. Go for Myers. Hello. Oakley dokley. Sure. Bye. So we know what to do there, yes? And logically, we just saw what to do here. Root x plus root y. What would go here? Okay. Everybody agrees they know how to do this, yes? Because it would be x times x, then 2 times 2. We don't need to do the oi of oil. FOIL, right? Okay. So look at B and tell me what is similar, what's different. Which color does B look the most like? Black, blue, or green? You are telling me that that looks like that. No. What one does it look most like? Green. Okay. So, according to the green one, what do you think our conjugate here would be? Two root 3 minus root 2. Now, you're right. So what would be the numerator be? Same thing, because it's got to equal 1, right? Now, something new is happening here. Whoops. Something new happens here. Because when we had this, what were we able to multiply by here? We just had to deal with the root 3, correct? We could forget about the 2, couldn't we? Why did Hayden have to leave that 2 there? What would happen if he didn't? It wouldn't cancel out, would it? Because you would skip the oi, well, you get 2 root 6, right? 2 root 9. Then you would get minus 2 root 6, and then you would get plus root 6. Did that disappear? No. So we have to remember, with binomial denominators, I'm so lazy, I'm writing binomial denoms. We must, capitalized, highlighted, Mrs. Bad Crumble cloud around it, because it's part of the shape of our day. We must include coefficients. Yesterday, coefficients actually got in our way, didn't they? They made it more complicated, so we just threw them out. But we can't do that here. Okay? Now, when you look at this problem, you see a mess. But I would submit that as long as you deal with everything in order, you'll be okay. I know that denominator is easy to deal with, right? Because when I'm doing the denominator, what is the only multiplying I have to do? First and last, right? So what is this one? And I'll color code. What is that one? 4 root 9. Now, I know that all of you know that is 12. And I know that all of you know that you can do that in your head, which is fine. But please notice how many multiplications are going to happen here. I don't mean to put you down, but a great many of you cannot hold that many multiplications in your heads. So what is the remedy to that? Write it down. If you don't need to, don't. And then, of course, minus, I'll change colors because I want to color code everything, minus root 4. Right? Now I said finish as far as you can. Well, that is 4 times 3 minus 2, which equals 12 minus 2, which equals, oops, I've gone, sometimes, what an idiot. Sorry, everyone. 12 minus 2, which equals 10. And now I can forget about the denominator. It was easy. Let's get it out of the way. I'm halfway done the question. Now, can I forget about any parts of my double distribution in the numerator? No, I gotta do it all. So what's that first one? 6 root 6. What's that second one? That should have been red. What's that second one? Plus or minus? Minus 3 root 4. What's that third one? 2 root, plus or minus? Plus. And what's that fourth one? Minus root 6. Now I'm going to simplify here. I got 6 root 6's. I'm taking away 1 root 6. How many root 6's? 5 root 6. What is the root of 4? 2 times 3, negative 6. What's the root of 9? Times 2, plus 6. Hey, look, they fell apart. 5 root 6, 5 root 6, because it doesn't simplify. Can I do anything there? What? Right. What does that become? Root 6 over 2. Because I can take a 5 out of there and a 5 out of there. Just like if I was doing fractions. Everybody good? Okay. What do you want to do with C? Because you got a couple of options there. You could simplify first. Where would you simplify? 2, 3, or 12? So that's going to get me 2 root 2 over, how do I simplify 12? So what would it come out as? 12 root 3? 6 root 3 minus 4 root 3. Now, when I do that simplification, what happened? I can tidy that whole denominator up. Now I'm never going to need FOIL, am I? So what do I get as a new denominator? 2 root 2 over 2 root 3, right? Now what? I could multiply by the root 3. Could I do something else first? Can't I kill the 2's? So now I got root 2 over root 3. And what bothers me there? Root 3 over root 3. And what do I get for an answer? And I'm done? Yes or no? You are done, even though some of you will say, oh, 6 divides by 3. Why can I not do that? Because one's a radical and one isn't. Is everybody good? Okay. Turn the page over. What's different about D? Looks-wise. It has a variable in it. Does that change our method of attack? No. So, since I've got a binomial denominator, what do I know I must multiply by? What do I call that thing? Calls with a C. Starts with a C. Ends with an E. Has conjugate in the middle of it. Right, I multiply by the conjugate, which is what? The root of 4x minus 1. Same numbers, different operation. And then I just go to work, right? So let's go to work. What do I have? Where do you want to start? I personally work with the denominator usually all the way through. Like, just because stuff's dropping out of it, right? That's just me, though. Where do you want to start? Where would you start if this was on your paper? You would start with the denominator? Okay. So do we care about the middle? We only care about the first and the last, right? So what's first? This is tricky. Square root of what? 16x squared. You got to remember your exponent laws. And then we only care about the last because we know the middle's dropping out. What is that? -1. And then we can tidy that up, can't we? What's the square root of 16x squared? 4x minus 1. Yeah? Everybody good? Okay, what's the top going to be? This is again going to be a little tricky. Hold up. What? 6 root 4x minus 6. Can I do any simplifying there? The 4 simplifies, doesn't it, Hayden? How? Square root of 4 is? So what's coming out of there? What does that do with the 6? 12 root 6 minus 6. Right? Everybody okay? Now, our next unit is factoring. Oh yeah, 12 root x. Sorry, thank you. 12 root x. I was worrying about the 6. What? I don't expect a lot of people to remember factoring because it's one of those skills that only really applies in math class, and you haven't been in math class for a while. So if you got to here, I'd let you go. But is there something you can do with that and that? What works with 12 and 6? 6. So I could bring out a 6, and I'd be left with 2 root x minus 1 over what? Do I need to change anything here? No. That's where I want you by the end of next unit, when I remind you how to factor. This unit, I'm perfectly happy if you're there. Everybody cool? Jacob, hit me. No. Oh, I might give you, if you actually did that on this test, right? Like I may throw you that bonus mark or something. Everybody cool? All right. Now look carefully at E, because E really screws kids up because they aren't thinking about it. The root extends. So what do I need to multiply by? Is this a conjugate situation? It really isn't, is it? So what am I multiplying by? The root of what? 4x plus 1. I thought you said minus 1. I'm sorry. Okay, so no big deal. We know the the denominator is what? 4x plus 1 now, yes? And what's my numerator? Now, is it done? This is what I mean by it's going to get tricky. Is it done? Jacob says I can bring out this 2. Can I? If I had this, 4x times 1, could I bring out that 2? Why can't I this time? Because technically, this is all one thing, isn't it? If I were to write this numerator as an exponent, it would be 4x plus 1 to the 1/2, wouldn't it? Right? And am I allowed to put that in and distribute it when it's a plus? No. So I'm done. Okay? Does everybody see that? Please recognize the difference. This is a binomial. This technically isn't even a polynomial because it's got rational exponent. Everybody cool? Okay. I am only going to do F with you. All right? And then I'm going to shut up, walk around a bit. The other class, I did 4 laps of the room, and then they decided they wanted to see some right answers. So we'll just start working, and then we'll see how you all feel, okay? What's weird about F? The whole thing is the square root, yes? So how could I write this? Sorry, I didn't mean to get the 6 in there. How could I write that in a way that looks like what we're doing right now? You would have root 4y over root 12. Now, where would that 6 go? With the 4y or with the 12? Or in both? Which one? With the 4y. Do I need anything here? Why not? Because that's 6 times this, right? So this is really 6 over 1 times that root, yes? Now, can we do some simplifying? Is this the same as 4x minus 1 plus 1 under there? No, it's not. Can I take out this square root now? Why? What's different? It's multiplying this time, right? So it can come out and get what? 12 root y over what's happening down here? Yeah, root 12. How do I deal with that? You could multiply it. You could leave this as root 12 and then multiply by root 12, right? That's one option, root 12, and we could follow that through. Is there another option? 12 root y over, I could simplify that to 2 root 3, yes? What does that green one allow me to do with 12 and 2 now? Break it down to, back down to 6 root y over root 3, right? And then if we were to finish this one, we multiply by root 3 over root 3, and we get 6 root 3y over 3. What would we do there? What will we do here? 2 root 3y. If I follow Ashton and I go root 12 over root 12, I then get 12 root 12y over 12. The 12s cancel. And now I've got root 4 times 3 times y. Bring out the 2 root 3y. Who's right? Ashton, blue, or Hayden, green? Both, because what did they both get to? The same answer. I don't want to force a method upon you. I try to show you as many ways as I can. I know some of you argue that that is confusing. But I argue it is infinitely more confusing if I only show you one way and you don't get it. Understand what I am saying? It is the most difficult part of teaching math. If I only show one way and 3 kids don't get it, they're never going to get that unless they go out and find it on their own. Sometimes I show 2 or 3 ways and some kids still never get it, but then I don't know what else to do then. Everyone's cool? All right. You start trying, and this is going to get a little weird because I printed my computer badly. You are going to work on 47 through 50 today. Tomorrow in class, we are going to have a quiz, and 51, see, I've printed it twice on my screen. 51 and 52 are your unit review, which we will work on tomorrow. We'll quiz, we'll mark, We'll start this. That's Wednesday. We'll finish this Thursday and mark it Thursday. And then, sadly, it's a 3-day week and we got to have our test next week. Okay? Everybody good? All right. You go get your water. You go pee. Go. Yes. Okay. The first one, root 7 over root 7 minus 2. The first thing you must remember is this is not allowed. So I have to multiply by root 7 plus 2 and root 7 plus 2 because I need the conjugate. Now, color coding. Root 7 times root 7 is root 49. Root 7 times 2 is plus 2 times root 7. Over. Again, color coding. First to first, because I only care about the F and the L of FOIL. That is root 49. Then, last, that should have been green, minus 4. And then I just simplify. 7 plus 2 root 7 over 7 minus 4, 3. Done. Okay? This one, I must multiply by root 2 plus root 3 over root 2 plus root 3. Then, again, I will color code. 3 root 2 plus 3 root 3 over first root 4 last minus root 9. Tidy it up. 3 root 2 plus 3 root 3 isn't going anywhere. 2 minus 3 is 3 root 2 plus 3 root 3 over negative 1. If you leave it that way, you're technically done. But do we like a denominator of 1? No. So all we do is we make it negative 3 root 2 plus 3 root 3. Bring the negative up here. Or negative 3 root 2 minus 3 root 3. But this is the one, after we do our factoring unit, that you're going to say, all right, we're not supposed to leave a negative there, so I got to bring it out anyway. Okay? Everybody good? All right, I will pause the recording. And I'm going to get root 24 plus root 16 over 12 minus 8. Yes? And that will get me 2 root 6 plus 4 over 4. Now, what does every single one of you want to do that you are not allowed to do? All of you want to do that. You cannot. Because what this really is 2 root 6 over 4 plus 4 over 4. Now, if this was Mrs. Bad Crumble's grade 3 class when you were learning fractions and you had never seen the square root before and you only saw 2 over 4, what would you do? Simplify it to what? 1/2. Root 6 over 2, 1/2, 1/2, plus what? 1. 4 over 4 is 1. It does not disappear, which is why I don't like that you guys have always been taught to cancel when you see that, because you think it is disappearing. It is not. That is why I teach exponents with canceling, because it's all multiply. But how many times did I mention, as Jacob just figured out, that they're not disappearing, they're becoming 1 and 1. 1 times 1 times x is just x. The x's don't miraculously disappear, they just become coefficients of 1 that we don't write down. That is why you cannot do that, because these are not coefficients. This, of course, 4 plus root 14 over 4 plus root 14. And again, I'm not going to simplify, mostly because you can't, right? So this becomes 4 plus root 7 times 14. Now, I like to work in my head every chance I get, but maybe I'm bad at multiplying. I know that's 98, but maybe you don't. I'm going to leave it that way, and I'll show you why in a second. Over 16 minus 14, which is all over 2. I left it this way because 14 is 2 times 7, yes? There is your pair, 2 7s. 4 plus 7 root 2. Now, a great many of you are going to want to do something here. You can't. It is 4 over 2 plus root 7. Plus 7 root 2 over 2. This doesn't cancel. This becomes 2 plus 7 root 2 over 2. Again, best answer, acceptable answer. Okay? Because the green one obviously shows me more understanding of math. Everybody good? Wait. Oh, I forgot the first root 7. Thank you, Jacob. 4 root 7. I forgot that first root 7. What a dunderhead. So this is, of course, 4 root 7. So it is, of course, 2 root 7 plus 7 root 2 over 2. Whew! Thanks, Jacob. Well played. I'm still a dunderhead because I forgot it. Over here again, acceptable, better. A gets really big because of the coefficients and such. B can get a little bit large as well. Yulia. Where? Here? So you're saying you want to make this what? Okay, it's the same thing as the other way around. This is really root 7 over 4 minus root 7 over root 14. You can't do that because this is all one thing. Okay, it's just like over here where we can't take just part of it. Oh. Whew. Tuesday. Tuesday stinks. Not for me. I don't get a Friday off. Let me tell you something. Ask every one of us, and we will all say we would rather be here with you people than doing Kirby. Sometimes. You think that's fun? Yeah. What bothers me most about them is very often the people doing the presentations are no longer teachers. So they are telling you things that we should do in my class that they do not do because they don't have a classroom in which to do so. No. I have done it in the past. I don't like it. Very rarely very rarely if I come home from a professional day and I'm like, damn, it was so much better than spending the day with this. Very rare. I get 6 professional days a year. I'm teaching for 21 years. It's 126 professional days. Let's see. Allie, you're in charge. Class. Go into the washroom. Be strong.
I will.
Be strong. Don't let Ashton push you around.
I want to go. Hey, class is over.
How were they, Allie? Awesome possums. Whose birthday?